going to do number 6, since 5 is posted with A block and 7 is posted with A block. And they're all asked for equally, so. Alright. Alrighty, let's see. So probably what I would start off with is recognizing, is there a before and after in this problem? Who's working on this problem with me, just so I know who to make eye contact with? Okay. Is there a before and after with this problem? Yes. Therefore, we must do a diagram as part of our Y. So we don't give away 40%. Alright, so I'd probably start off with, this is number 6, probably start off with something like the club and ball are a system. And then momentum is conserved in the system. Alright. Probably most I need to express. I could also, express to show that I understand what momentum is. Like momentum is inertia in motion. Probably wouldn't be a bad thing to express there. So that would be what I would put for my Y. My diagram, I have the ball and the club, and then they stay separate afterwards. And let's look at the situation here. Remember, don't be intimidated if you can't draw as well as me. Alright, so momentum of the ball beforehand, 0. Momentum of the club beforehand would be in that direction. Momentum of the club afterwards would be in that direction. And the momentum of the ball afterwards would be in that direction. So that would be my momentum diagrams for this one. So let's see. Start with valid physics equations. Momentum of the system before equals momentum of the system afterwards. And momentum is inertia multiplied by velocity. And so before the impact we have 2 objects, afterwards we have 2 objects. So momentum of the club plus momentum of the ball equals momentum of the club afterwards plus momentum of the ball afterwards. Nicely, this is 0. We've got inertia of the club, velocity of the club. Sorry, these should all have vector symbols on it. Equals inertia of the club, velocity afterwards of the club, plus inertia of the ball, velocity of the ball afterwards. Yeah, it just didn't track well. So I'm going to look out, let's see, the inertia of my club is 0.260 kilograms. So 0.26 kilograms. Velocity of the club beforehand is 55 meters per second. Equals inertia of the club 0.26 kilograms. I'm assuming to the right is positive. Sorry, I should have said that earlier. velocity afterwards of the club is 44 meters per second. Plus the inertia of the ball, 0.046 kilograms. And the velocity prime of the ball, which I'm predicting is going to be to the right. They don't tell us that, right? All right. So all numbers except for the velocity of the ball. Do your calculations and solve for the velocity of the ball. I would, but someone stole my calculator or borrowed my calculator. All right, and you'll end up with it in meters per second. You've got kilograms, 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 so you should end up with meters per second. All right. Let me know if you need help individually on that. All right, so let's do number 4. Train cars couple together, but if we bumped into one another. So, is this a situation that had before and after? Yes. So, need to do a diagram. And I would say the 2 train cars, we can assume that the 2 train cars make up a system. So, this is number 4. 2 cars are a system. Momentum is conserved in system. Probably need to mention their momentum is a vector. Wow. There's always been, you need to refresh the page. It's updated every Sunday. So if you look down the bottom and you notice it's not Sunday's date, you need to realize you probably have the wrong week up. So beforehand we got cars. How do they note them? I'm going to call mine the 120 and not 105. So this is the 120 and this is the 105. And so the momentum of the 105 is going that way to start. Momentum of the 120 is going that way. Afterwards, they become one body. We'll call it one body, we'll call it the 225. And I'm predicting that it's going to go in that direction. So, there are my momentum diagrams. This could actually, as we'll talk about tomorrow, this could actually be also called a inelastic collision. All right? But we're going to look at it as a system. So, momentum of the system, 4 is the momentum of the system afterwards. And momentum equals mv. So, momentum of 120 plus momentum of 105. Those they're added because they're vectors. It's the momentum of the 225. So this would be the inertia of the 120, velocity of the 120, inertia of the 105, velocity of the 105 equals inertia of the 225, velocity of the 225. So then I would just substitute in my values. I know the inertia of the 120. I know the velocity of the 120. Right? let's see, inertia of the 120 is 120,000 and 0.3. So I'm going to do 120,000 kilograms times 0.3 meters per second. I think it's meters per second. Yeah. And then 105 kilograms in negative. So plus 105,000 kilograms times negative 0.12 meters per second. That all equals the 225,000 kilograms, which I got by adding up the inertias of the two times V225. And I'm predicting positive. Hopefully we'll get positive. Not we'll get negative. All right. And just do your calculator or do the math on it.